Anne planned to spend 1.5 hours to cook a meal. Instead, she finished the cooking in 1 1/12 hours. So how much earlier did she finish cooking than she expected to, is the question. Let's start off by trying to figure this question out using our bar model. So let's draw a bar to represent 1 hour. That's going to be this bar right here. And now let's think about how we're going to represent the amount of time that Anne planned to spend cooking using the bar model. Well, she planned to spend 1.5 hours, 1.5 hours. So how do we represent 1.5 hours using bars? Well, one bar will represent the first hour, and then we need another half hour. So let's look at our original bar. There it is. So we will need another half of that bar in order to represent 1.5 hours. So let's add that onto our planned time. So that's how much time she planned to spend cooking. But when it actually came down to it, she finished cooking sooner. So let's try to represent 1 1/12 hours using the same bars. So to start off with, first she spent 1 hour cooking, and then she spent an additional 1/12 of an hour cooking. So now we're going to have to divide our original 1 hour into more fractions. We're going to, in fact, need to divide it into 12 fractions, just like that, to represent, to find 1/12 of that bar. So we're going to need one of these 1/12 sections, if you count that there are 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we need one of these little sections to represent 1/12 of an hour, and we're going to tack that on at the end there. Okay, so now what we want to do is we want to compare the difference between the amount of time she spent cooking and the amount of time that she only planned to spend cooking. So what we're looking at is this area here, and we need to find out how much time that represents. Well, it's kind of hard to compare 12ths and halves, so we need to divide all of these bars into 12ths. Just like that. So now you can visually see the difference between the time that she planned to spend cooking and the actual time. And I'm just going to use a different color so that we can see the difference. So there are 1, 2, 3, 4, 5 of these little bars that represent the time that she planned to spend cooking but didn't actually end up needing. So we have 5 of these little bars, and each of them represent 1/12. So she spent 5/12ths of an hour less than she intended to. In other words, she finished the cooking 5/12ths of an hour earlier than she planned. But let's think about this in terms of subtraction, now that we've seen how it works visually. So what the question is asking us is, if Anne planned to spend 1.5 hours cooking, but then she only spent 1 1/12 of an hour cooking, how much time was left over? So now we need to subtract one fraction from another, and in order to do that, we need them to be like fractions. We will need them to have a common denominator, which means that we'll have to find the lowest common multiple of 2 and 12, which is, if you take a second to think about it, 12. So we need the denominator of both of these to be 12. And we can leave the fractions as mixed if we want to, which means that we can leave the 1 in the front. So let's change these so that their denominators are the same. So 1 over 2 is the same as 6 over 12. And we're going to subtract 1 and, well, the denominator here is already 12, so we can just leave that. So we can start by subtracting the whole numbers first. So 1 minus 1 is just going to cancel out, so we can cross those out. And we are left with 6 over 12 minus 1 over 12, which is the same as saying 6 minus 1 over 12 because the denominator is the same. And the answer is 5 over 12, 5/12 of an hour, which is the same thing that we found using the bar model.